Today we're going to be talking about whether an object, if you put it in another substance, a liquid of some sort, would it sink or float? What determines whether an object will sink or float? We think about it, you've got little things that will sink, and then sometimes really big things like boats and things will float. So what determines that? Well, the main thing that determines it is something called density. And that's what we're going to be talking about. We're going to learn how to do some density problems. Density is basically how much material or matter is compact in a certain volume. And because of that, density is the formula for it is the mass of the object divided by the volume of the object. So it's a proportion. It's mass volume ratio, how dense something is. So one thing that we're going to talk about is whether things would sink or float in water. And so I would like you to know the density of water is approximately, and I'm going to use that word very loosely, approximately 1 gram per milliliter. That's about room temperature water. We know when water gets colder, it actually becomes less dense. That's why ice will float. So water, I'd like you to know 1 gram per milliliters. And so anything that would be more than 1 gram per milliliter in water is going to sink. So that is why wood will float and a rock will sink. This is more dense. This is less dense. We're not always putting things in water. Sometimes you're putting them in another substance, but most of the time we're talking about comparing to water. And so that gets us into, well, what is mass? Well, mass is the amount of matter in an object. So some of you may be taking physics and you'll be measuring mass in kilograms, but in chemistry our objects are so small we're going to be using grams as our unit. So grams will be our unit. And we measure the mass of something on a scale. We've already been doing that in lab. So remember, on a scale you always need to zero it out before you put your object on there. Or if you're using a weighing tray, you're going to put your weighing tray and tear the balance out. So volume is our next. Well, you should have learned in your math classes that a volume is how much space something takes up. So you can measure the volume of a regular shaped object by doing length times width times height. It was like a cube. And then you've got some other formulas if they're cylinders, etc. In lab we'll use some of those other mathematical formulas you used in maybe geometry to figure out volume, but for lecture we'll just stay with a cube, and then we'll talk about what we do with an irregular shape. So we're going to measure in chemistry, we're going to have small objects, so we're going to be measuring our length, our width, and our height in centimeters. So if you take a length and a width and a height and you multiply them together, you get centimeter times centimeter times centimeter. So you get a centimeter cube. So a length, a width, and a height of an object. So you can get a centimeter cubed for a rectangular or cube shaped object. Well, what if it's not solid but yet a liquid? So when liquids, we measure those in a graduated cylinder. You pour it into a graduated cylinder and then you see how much it rises up. So graduated cylinders measure the unit of milliliters, so any liquid substance is going to have a milliliter measurement. And you should always read the bottom of what's called the meniscus. Like for instance, this one's 50, that's 1, 2, and 3, about 53 milliliters this liquid is taking up in this graduated cylinder. And the reason we measure the bottom of the meniscus is because we have to talk about some terms, and if you've had a biology course, you might have studied these terms of cohesion and adhesion. And so if you look at this is a water molecule. Water molecule is said to be a Mickey Mouse molecule. It's got those 2 hydrogens and an oxygen. So cohesion is what holds two water molecules together. So these would be, I love this picture I found. So cohesion is with itself, and that adhesion would be it holding on to the side, like in a graduated cylinder, the glass or the plastic. So this is adhesion and this is cohesion. And so that's what causes the meniscus. And so the meniscus is the curvature that forms when your liquid is placed into a graduated cylinder. It adheres to the side, and so that's why we get that dip. And so when you're reading that, you should always get eye level. That's important. So always get eye level, and don't hold the graduated cylinder up. Sit it on a flat object, because when you hold it, you tend to tilt it. So sit it on a flat object, and then you're going to read the bottom of the meniscus. And the reason you don't want to, the reason you want to get eye level, if you are standing above and reading down, you're going to get a lower reading. And if you're down here, most of you probably won't have that trouble. Me, on the other hand, would probably, but sometimes depending on where I sit it, you would get too high of reading. So you want to always look eye level with that meniscus to the best of your ability. And again, don't hold it up to eye level. And so this just brings in that adhesion and cohesion. So most of our liquids prefer to adhere to the side. And so we get this concave meniscus, and so we would read here. And that's because the adhesion is more than the cohesion, that little intermolecular force. But there are a few liquids, like mercury is a good example. Not that we'll be dealing with mercury in lab, but cohesion is more than the adhesion to the container you're putting in. So you would get a meniscus that looks like this, and this is still a meniscus. You would still read the top of it. It has to do with the bottom going on down here, and I'll show you that in lab. So what I've learned is sometimes students don't know how to read a graduated cylinder. And so you will have a couple like this maybe on your test, but I want you to realize that I'm only gotten a picture of part of the graduated cylinder, so it doesn't show the entire graduated cylinder. So you have to be able to read a graduated cylinder to get volumes. And so I've got 3 different examples here. And so let me take a picture of these. Okay, so first thing you want to look at is you want to look at your measurements. Students always assume 10, but they're not always 10. So you want to look at your measurements. So you want to take your numbers and see how much is in between them. So this one's 50, this one's 40. The difference between 50 and 40 is 10. Okay, and then you would count your lines. 1, 2, 3, 4, 5. I must count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so there are 10 lines, and there's 10 spaces between. So each one of those is just 1. And so this one's pretty easy. So you would measure. We know that one is 45. This would be 46, 47, 48. Not just 48, but because this is a graduated cylinder, this would be 48 milliliters. All right. So when you look at this one, you want to look here. The difference between 27 and 26 is not 10. It's just 1. So that's the top number. I would count how many lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So each of them is a tenth, or 0.1. So I know this is 26.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this is 26.7 milliliters. All right. Most students don't have trouble with those two. It's this one that we have trouble with. And there's not always 10 lines. Sometimes there's only 2 lines. Sometimes there's 5 lines. So you have to count how many lines there are. So in between, let's do this first. 15 minus 10 is 5. So I'm subtracting the bigger number and the smaller number that's printed on the equipment. And then we count the lines. In this instance, again, there are 10. So 5 divided by 10 is a half. Or shall we say everything's 0.5. So that means we know this is 10, so this would be 10.5. So this next line would be 11. This one's actually 11 milliliters. Okay, and this was what usually gives students a hard time, is when they're 5 between, and so realizing that each line is a half. Okay, so I need you to be able to read a graduated cylinder. All right. So now we'll talk about, well, what if our object's like a really weird shape object, maybe like a rock or something? Then we use water displacement, and you should have hopefully did this in high school where you did some water displacement and did some calculations with density. So we'll get to that in a second. So for instance, if I've got this rock here and I want to figure out its density, or I do want to find its density, but I want to find its volume. So volume for a normal regular shaped object, length times width times height, or one of those other mathematical functions that you've learned in geometry class. Or we could take it and put it in a set amount of water and see how much it displaces. So you see here, we're starting with this at 7 milliliters. I'm going to take and put that rock in there. Rock has taken up some space, and you'll notice the water has gone up to 9. So the difference between those two, the 9 milliliter and the 7 milliliter, is 2. So the rock has gone up, pushed the water up, I should say, 2 milliliters. But milliliters is a unit that we use for solid objects. For liquid objects. Solid objects we use centimeters cubed. And honestly, they are used in the medical community back and forth. 5 cc's. cc's is a cubic centimeter. Cubic centimeter means 5 milliliters. So you guys that are going into medicine, you're going to see cc's, which is cubic centimeters. In chemistry, well, then we go back and forth. We just say that they're equal to one another. So centimeter cubed is the same thing as milliliters. We usually use centimeter cubed if the object is a solid, and milliliters if the object is a liquid. So the water went up in milliliters, so this was 2 milliliters displaced, but the rock would be 2 centimeters cubed, and they are equal to one another. So however many milliliters it moves up is how many centimeter cubed the solid object is. Take a picture of this where we can write. Okay, so the question says, what is the density of our object that has a mass of 456 grams and a volume of 225 centimeters cubed? Because it's a centimeter cubed, we know this thing is a solid. And we're going to decide whether this thing would sink or float. So would like you to do this is how I want you to set these problems up. You're going to write the formula you're using. They'll plug in with your correct units and the answer in the correct unit and significant figures. So our formula is density is mass divided by volume. And then density equals the mass is 456 grams divided by the 225 centimeters cubed. All right, so when you put this in your calculator and divide them out, you get 2.0266. So now we want to practice using significant figures. This one had 3. This one has 3, so we need our answer to have 3, and we are going to round appropriately. This would be 1, 2, 3. Now this is a 6, which is going to cause that to round. So the answer is 2.03. And notice that neither one of these units have anything that cancels out. Density always has 2 units. The unit is grams per centimeter cubed. That is our density unit there. So this is more than 1, so if we were to put it in water, this thing would sink. Okay, and the reason is because it is more than 1 gram per milliliter. Water's milliliters because it's liquid. All right, so that's just straightforward solving for density, so super easy. So let's look at our next problem. All right, so this one's looking for volume. And so if we think about it, this is the reason I'm going to show you this, because some students have a hard time manipulating the formula. So the formula, let me go to a blank page just to show. I'll come back to that one. Okay, so here's our density equals mass divided by volume. And notice how volume is on the bottom. Some students have trouble when X is on the bottom. They end up dividing backwards, etc. And so this is where a little triangle comes in. And if you've ever used these, and I'm not trying to make it, it's just density is so easy. I don't need you to miss density problems just because of the algebra. So the way this works is the M is on top and then the D and V are on bottom. I had a high schooler that made up a little sentence to help you remember what's on top. It says mountains. Mountains are always on top. Mountains over Death Valley is what the high schooler said. So works out. So just remember M's on top. The way this works, let me grab my little eraser circle here. Whatever I'm looking for, this little triangle will give me the formula. For instance, if I'm looking for density, I would put my finger over the D, and that tells me to take the mass and divide by the volume. If I'm looking for volume, which is what I'm doing right now, that tells me to take the mass and divide by the density. Okay, we need to watch the density, make sure the units are going to jive with it. And then if I'm looking for mass, look what you're going to do. You're going to take the density times the volume. It's just a real quick way to manipulate this formula. Not that you can't do it. It's a super easy formula. It's when you're solving for volume is when students will mess that up. So let me head back to my pen here. So again, that is mass. Ooh, don't know what happened to my S there. It is mass. Mass is going to be measured in grams. Okay. This is volume. Volume is going to be measured in milliliters. I just made that capital L. It doesn't matter. If it's a liquid, or centimeters cubed if a solid. So, but they're the same. I mean, they're the same, but it's just a labeling thing. So density doesn't have anything that's going to ever cancel out. Now, I want to say with a thing, we're doing solids and liquids. Our last unit is gases, and our density for gases are going to be grams per liter because they're going to be the least dense, least compacted. So we measure the volume changes to liters. But we're not going to do gases yet. We'll wait and do gases at the end. But, so for density, which is what the D stands for, it's going to be 2 units, gram per milliliter or gram per centimeter cubed. Well, this one's if it's a liquid, and this one's if it's a solid. The one we just did a second ago was a solid because it had a centimeter cubed there. We saw it was a solid that would actually sink. Okay? So I can get back to my problem here. All right. So with that being said, I'm going to come down here and draw my little triangle. And it's mountains over Death Valley. So our formula, we're wanting us to find volume. Okay, so volume here. So volume, if I put my finger over this, is the mass of the object divided by the density of the object. Volume is the mass divided by the density. So if I start reading this problem, you'll see the density has its unit of gram per milliliter, meaning this substance is a liquid. Does have some mass, but it's milliliters of liquid. And notice that the mass is in kilograms. Well, if I go back, remember I said that our masses here in chemistry are going to be measured in grams. And that really has to do with the way our densities are measured. It's measured in grams per milliliter. And so if I'll notice here, my density's doing okay. My density is 0.0865 gram per milliliter. So if I were to put that 36 kilograms on top, you would notice that nothing cancels out. And you can't, we don't want 3 units. So this kilograms is going to have to be converted. And since we're still working on dimension analysis, I am going to make you show that work. So before I even start this problem, I need to convert this kilogram into grams. If I use my conversion sheet from the dimension analysis, I will notice that kilo has a 1 in front of it, and kilo is always 1,000. That's just something you might want to learn. It's 1,000 of whatever you're talking about. A kilogram's 1,000 grams. A kilometer is 1,000 meters. A kiloton is 1,000 tons. So a kilo something is 1,000 of whatever those somethings are. So that's going to give us 36,000 grams. We won't worry about significant figures right now. We're not at the end answer. So now that this is in the gram unit, I can put it over here and watch what's going to happen. I'm going to get a blue, I guess. Do you see that those grams are going to cancel? And that divide by and that divide by makes that milliliters pop to the top. So milliliters is the only thing that's going to be left. Oops, I guess I'm staying in blue. Milliliters. So I'll just stick that number in my calculator. And so you get a number of 41618. Now, this is our end answer, so we want to talk significant figures. Up here in my beginning problem, that's where you always want to look. That has 3 significant figures, and that has 3 significant figures, so our answer needs to have 3. That does not mean you change this answer to 416. What that means is you can do 2 things. You can put it in scientific notation. So I can go 1, 2, 3, 4. So 4.16 times 10 to the, this is more than, anytime it's more than 10, anytime this number is more than 10, it's going to be a positive value. So it's that many milliliters. Or you could just round this to 416, but you need to put zeros at the end. Remember, ending zeros are not significant. So these are my correct answers. All right, so that's a pretty big volume, pretty big mass too. So my question to you, it's a liquid, taking up a really large volume liquid. If I put it in a water, would it sink or float? And so most of the times people tell me that this thing would sink because that's much more than 1. But remember, it's not the volume, it's not the mass, it's the density. The density is what we look at. And this density of this object is 0.865. So 0.865 is less than 1. So this liquid will float. Because our density is less than 1. Okay, not too bad. On to the next one. Oops, that's our other picture. All right, last example here. We've got what is the mass of an object. And so I've been given a volume here. And I've been given a density. And if I go to my triangle, the formula is mass, because it's on top, is the density times the volume. So my mass is the density, and the density is 2.98 gram per milliliter. And so my volume here, according to this, needs to be in the density tells you what units everything needs to be in. The mass needs to be in grams, and the volume of this liquid needs to be in milliliters. Do you notice up here? I gave it in liters. So what we're going to have to do before we use it, we're going to have to convert it. We're going to convert it, and yes, I do want you to show it. Later, past Unit 1, I'll start letting you do some things without having to show the work, such as going from milliliters to liters. But for now, so liters would come down, milliliters to the top. If I go to my sheet, millis are little, and there are 1,000 millis in 1 liter. Liter has the 1 with it. So I'm going to multiply by 1,000, which is going to get me 550 milliliters. 550 milliliters. And so now you can see, trying to do a different color there, those milliliters will cancel out. And I'm just going to multiply. I'm going to get a pretty big answer. I get 1,639. Can you see that we're going to end up with grams, which is what mass should be in? That makes sense. But we got a problem. This has 4 significant figures, but up here, my 2 beginning numbers have 3. But I'm not just going to go 164 because that would not be the same. So I could round this to 1,640 grams, or I can go 1.64 times 10 to the 1, 2, 3. It's going to be positive because that's more than 10. Remember, if our number's more than 10, it's going to be a positive value. That way you don't get trapped in left or right. Is this object going to sink or float? Well, we don't look at the mass, we don't look at the volume, we look at the density, and our density is more than 1, so this is going to sink. Okay, super easy problems. Let me show you one last thing. Gotta find where it is. Alright, I'm going to show you one last thing here, and I just took a picture of a cube here. So we're just going to say that this cube has a mass of, we'll make our numbers easy, let's say 40 grams, okay, and the volume of this is 20 milliliters a centimeter cubed, solid centimeter cubed. And so I want to know what the density is. So the density is the mass divided by the volume. So can you see that this square would be 2 grams per centimeter cubed? Okay, so this guy was 20 centimeters cubed. The mass. So now I want to take this same cube and I want to cut it in half, and now I just want to know what the density of one of these, not both of them, just one of them. Okay, so, well, mass is an extensive property, so if you have more of it, it's going to weigh more. If you have less of it, it's going to weigh less. It changes because of the amount. Okay, so it's going to weigh, if it's cut in half, it's going to weigh 20 grams. Yep. Volume is also an extensive property. Extensive means you change the amount, you change the value. So if I half this, the volume, the space it was taking up, the whole thing was 20. Half of this would only take up 10 centimeters cubed. But if I do the math here, what is the density? Can you see that? The density stays the same. It's how we can determine objects. That's what you're going to do in lab. I'm going to give you these different metals, and you're going to figure out what metal I've given you based on the density. Because metals have the same density, because that's how we can tell that gold is gold and copper is copper, etc. So density is intensive or extensive? Intensive. Intensive is a property that does not change if you change the amount. Mass, extensive. Volume, extensive. Changes the amount. But density, because it's a proportion of those two, that proportion would always get us back to the same number. So I do need you to know that. All right. That's about all there is for density. If you have any questions, you know what to do.